Good morning, Year 11s. Welcome to video on quadratic formula, which is used for solving any quadratic and is really quite a lot simpler than completing the square. So, when you have a quadratic in this form, where a is not equal to 0, the solutions to it are given by that equation, and you simply sub the numbers in. And you should have seen that in Year 10. Now, the proof for it is beyond the scope of the course. If you want to find the proof, then Google proof for a quadratic formula. It's kind of cool, but let's just practice it on using it. So if we want to use this, we have A, B, C, and I honestly would label them. And then we know that x is equal to, you can sub into the formula. So I would write minus b is minus 5 plus or minus the square root of b squared. Take 4 times a times c over the top of 2a. And then let's simplify. X equals minus 5 plus or minus the square root of 5 squared is 25 minus, well, 4 times 1 times 6 is 24. 25 minus 24 is plus or minus 1 over 2 times 1 is 2. Square root of 1 is 1. X equals minus 5 plus or minus 1 over 2. Therefore, x equals minus 5 plus 1 is minus 4. Minus 4 on 2, minus 5 minus 1 is minus 6 on 2, x is equal to minus 2 or minus 3. Alright, let's think of another way of doing this. We could factorize this. Factorizing, it's got a 1 at the front, adds to 5, multiplies to 6. So if we're going to factorize this, x plus 2, x plus 3 equals 0, therefore x is equal to minus 2 and minus 3. Which is cool. Same answer. The point I'm trying to make is quadratic formula always works, but it's painful and long and has lots of potential for errors, whereas if you can do it by factorizing, fantastic. Try factorizing, and I know it's very easy in the textbook section where it says quadratic formula at the top, and then you're expected to just use quadratic formula. However, in a test and the revision sheets, you'll be given a quadratic and won't necessarily know whether to factorize or quadratic formula. My advice is try to factorize first. Doesn't work, sure, go quadratic formula. Alright, let's go just one more example for something that cannot be factorized. Alright, so A, B, C, x, and note that it has to be in general form, has to be 0 on the other side. X equal to minus b plus or minus the square root of b squared. Take 4ac. Note that in maths we sometimes use dots in place of multipliers, just because multipliers get in the way a bit, over 2a. And note that I haven't tried to simplify this as I go. I haven't written 9 there, and I haven't done that in my head. I've just put the numbers into the formula exactly. So then we have minus 3 plus or minus the square root of. Now that's 9 plus, because the double negative, 56. 2 times 4 is 8. 8 times 7 is 56. Over 4 equals minus 3 plus or minus the square root of. That there becomes 65 on 4. Now, the question I guess you have next is, what can you do to simplify this? There are possibilities sometimes. So typical possibilities would be trying to simplify the root 65. And root 65, you can try and simplify it by pulling out a perfect square factor. So if you could pull out a factor of 4, 9, 16, 25, from there, you could simplify that. But you can't really do much. Similarly, if there was a 4 and an even number here, you could divide out some 2's, providing there was a 2 coming from that as well. But in general, well, in this case anyway, you can't simplify. So that would get you your full marks. Alright, that's given you a couple of brief notes. We will do more practice in class. Thank you very much.